Hi, my name is Francisco, and I am the CEO, and we are the team behind TIM, Testing and Irradiation of Materials. Right now, we are seeing a lot of new companies in the advanced nuclear reactor space, and they all seem to have very tight deadlines, and because they want to come into market as fast as they can. But we also know from experience that developing a new reactor design takes a long time. In fact, after the Fukushima incident, there was a push to develop accident-tolerant fuels, and those are still in testing right now, and they are predicted to finish by 2020, which is a 10-year period. So there's a discrepancy between the timelines of the companies and the timelines that take to test, and we hope that our solution will help bridge that gap. Now let me give you some key facts. Again, it takes 10 years to develop a new design, and most of that time is spent in testing. Testing happens in testing reactors around the world, and they're usually full and have extensive backlog. There are about 20 testing reactors, but only 5 of them were built for that purpose, which means they offer very low flexibility. They're expensive, and sometimes they're outside of the country, which means that we need additional regulations and maybe additional costs. Finally, the Holden reactor in Norway is closing down, and that will mean about 5,000 fewer testing hours per year available for testing. But on the other hand, we have 50 startups that require a lot of testing and need these testing facilities. So what is our value proposition? We offer faster, versatile, and cheap ways to test materials, nuclear fuels, and other devices for advanced reactor designs. And we call this TIM. And now I'm going to pass to Jake, our CTO, who's going to explain the technology.
Okay, thank you, Francisco. So our device at TIM is coupling a neutron source with a subcritical assembly. So the neutron source is a fusion DT source provided by Phoenix Labs. And the device I'm showing here is the neutron source pointed at a subcritical metallic fueled assembly with a coolant loop. So this is a lower flux facility than you would find at actual test reactor, but it's subcritical, which means the licensing process for something like this is much easier than if we were doing a full reactor. And also, it allows us to provide a lot more capabilities than you would find at these big test reactors, like corrosion testing and confirming neutronic models before these new reactors go out to market. And because we are a subcritical facility, we could also easily change out the target. So instead of the metallic fuel, this is an example of a liquid fuel target. So this is a subcritical design that you would see for like an MSR, a molten salt reactor design. We also want to help customers that come to us with a sample preparation before it goes into the subcritical assembly, and also with post-irradiation characterization. So now I'm going to hand it off to Brian, our COO, to talk about the value we provide to our stakeholders.
Thank you, Jake. So for our company to succeed, one of the most important things is to maintain relationships with all of our stakeholders. So our primary stakeholders are the startup nuclear companies, which will be our main customers. So we want to be able to customize our facilities to be able to address the specific testing needs of each individual company. Next, we also want to provide our services to academia and national labs. Although we want to prioritize startups, we believe we'll also be able to help research in new materials and fuels. Next, we want to work with nonprofit nuclear organizations. And lastly, we want to be able to maintain good communication with the NRC to make sure all of our licensing goes smoothly and efficiently. We are also exploring the possibilities of partnering with Phoenix Labs in order to maybe assess the feasibility of a shared revenue stream. So we've done some basic financial projections, and we'll be able to finish construction by the end of year 3, start generating revenue by year 4, and being able to turn a profit by year 7. Next, I'd like to hand it off to Charles.
So our team consists of Brian, myself, Francisco, Nicole, and Jake. We are asking for $5 million or 20% equity in our company. Thank you.
Okay. All right, and now we have 4 minutes from the judges.
So can you tell me more about the neutron source and how you're going to compare on a timeline and cost to other alternatives?
Yeah. So some of the other alternatives are the 5 test reactors that exist worldwide, and those are high flex facilities. They get 10 to the 15th or higher, but they're not very flexible. Some of the other options are research reactors around the world, and those have comparable fluxes, but again, they have to go through huge regulatory burdens to put samples next to their core. So we're working with Phoenix, which has a neutron source that is the highest neutron source that currently exists in the world. That's not a reactor, and it goes up to 10 to the 13th. So do you have a follow-up there?
Can I just add a little bit? Can I have the clicker? We prepared a comparison with the MITR, and we can see that we have comparable neutron fluxes, capacity, power. We're both not NQA1 certified, which means we can't really test certify materials, but we can test them and provide data for the companies. And the MITR is always full and has a backlog, and this is the prices they practice, and this is our range. It will depend on the type of tests the companies would require.
Are you doing R&D work here, or is this primarily a play where you buy equipment from other people and assemble a facility that you then rent out?
So the one piece of equipment we are going to buy is the Phoenix device. The subcritical target after that does need to be developed. And it could be flexible that we could work with our customers. So if you come to us with a molten salt design, we'll help you create the subcritical assembly so it's safe and it has all the experimental ports that you need.
This facility, is it only doing neutron bombardment, or can it do multimodal failures related to thermal cycling or corrosion and molten salt reactors? Or?
So that's flexibility, the thermal cycling and corrosion testing that we want to implement. So you would do this by installing loops of different coolants. You could do this by having a variety of different fuels that the subcritical target is made out of. So we definitely want to provide those services, which is something all the test reactors can't do.
I was wondering if you operate at full capacity, if you have like a lot of people want to work there, is there enough tritium out there, or will we need another source?
That's an excellent question. So is there enough tritium out there? We would have to get back to you with that.
You can always make more, I guess.
That's an interesting question. There are other companies that are using tritium. So some people may be familiar with Shine Medical Technologies, who hopes to use a generator just like this one for Moly-99 production. So there are going to be a lot of competitors for this tritium out there. Okay, thank you very much.
Thank you.